Welcome dear learners. We are continuing Unit 2 Inorganic Chemistry Practical 1 Volumetric Analysis. In the present module we are discussing experiment number 8, that is estimation of copper. The contents of this module are iodimetry and iodometry, a brief mention, aim of the present experiment, principle behind the experiment, reagents required for the experiment, procedure of the experiment, that is preparation of standard K2Cr2O7 solution, standardization of sodium thiosulfate solution, and estimation of copper. Finally, results of this entire experiment. First of all, we are discussing about iodimetry and iodometry. You are familiar with the titrations involving iodine. There are two kinds of titrations involving iodine and they belongs to iodimetry and iodometry. I am just mentioning this concept in order to just remember the concept you have learned in the previous modules. So, iodimetry and iodometry. The volumetric analysis based on the use of iodine as an oxidizing agent is called iodimetry or iodometry. Iodimetry deals with direct titrations involving or using iodine solution. Iodometry deals with the titration of iodine liberated in chemical reactions. Before starting the present experiment, you have to make a clear-cut distinction between iodimetry and iodometry. In order to remember, you have to keep this in mind. Iodimetry involves titrations using direct iodine solution, whereas iodometry deals with titrations with liberated iodine. Now, aim of the present experiment. This about the aim of the experiment to estimate the amount of copper in the whole of the given solution of copper sulfate. Approximately N by 10 sodium thiosulfate solution and AR potassium dichromate crystals being supplied with. We are now entering into the principle behind the estimation of copper or principle behind the experiment. AR potassium dichromate crystal is used to prepare a standard solution with which sodium thiosulfate can be standardized. That is, you are first preparing a standard solution of K2Cr2O7 by taking accurate weight of fixed quantity of potassium dichromate, and using that standard solution of K2Cr2O7, you can perform a titration with the sodium thiosulfate. Based on that, you can estimate the you can standardize the given sodium thiosulfate solution. In the presence of hydrochloric acid, potassium dichromate liberates iodine from a solution of potassium iodide. This is the equation responsible for the liberation of iodine from potassium iodide by K2Cr2O7 in acid medium. K2Cr2O7 plus 6 potassium iodide plus 14 HCl produces 2 CrCl3 plus 8 KCl plus 7 H2 plus 3 molecules of iodine. It is very well clear that potassium dichromate can liberate iodine from potassium iodide in the presence of HCl. The equivalent mass of potassium dichromate in the present reaction is equal to 49. The liberated iodine in the above reaction is titrated with Na2H2O3 solution. Iodine oxidizes sodium thiosulfate to sodium tetrathionate. This is the reaction showing the oxidation of sodium thiosulfate to sodium tetrathionate. That is, 2 Na2H2O3 plus iodine gives Na2S4O6 plus sodium iodide. Since one molecule of Na2H2O3 reacts with one equivalent of iodine, the equivalent mass of Na2H2O3 is same as its molar mass. That is, molar mass of Na2H2O3 5H2O is same as its equivalent mass, and molar mass of Na2H2O3 5H2O equal to 248.19. copper 2 plus can liberate iodine from potassium iodide solution as per this equation. 2Cu2 plus 4I minus produces Cu2I2 plus I2. Here, the equivalent mass of copper is its atomic mass, that is 63.54. Liberated iodine can be titrated against standardized sodium thiosulfate solution to estimate copper. Now we are entering into the reagents required for the entire experiment. That is, reagents required for estimation of copper. These are the reagents. First one, AR potassium dichromate crystal. Next, approximately n by 10 sodium thiosulfate solution. Copper sulfate solution, which is used for the estimation of copper. Concentrated hydrochloric acid. 5% potassium iodide solution. Starch solution as indicator. Ammonium hydroxide solution. Acetic acid solution. And 10% ammonium thiocyanate solution. So, in general, these 9 reagents are required for the entire experiment. We are entering into the procedure of the experiment, that is estimation of copper. First part is the preparation of standard K2Cr2O7 solution. Mass of K2Cr2O7 required to prepare 250 ml of n by 10 solution can be calculated by using the expression for weight calculation, that is weight required equal to VEN divided by 1000. Here for the present case, weight required equal to 250 multiplied with the 49 multiplied with the 0.1 divided by 1000. So the weight required to prepare 250 ml of 0.1 normal K2Cr2O7 solution will be equal to 1.225 gram. Now, roughly first you have to weigh out 1.25 gram of AR K2Cr2O7 and transferred it to a dry weighing bottle. It is then weighed by an electronic balance as weight W1. The substance is transferred into 250 ml standard flask through a funnel and make up to the mark. The weight of empty bottle is now taken as W2. So, the actual weight of potassium dichromate taken will be equal to W1 minus W2. The weight W1 minus W2 is used to find out the concentration of the K2Cr2O7 solution as normality equal to weight per liter divided by equivalent weight. Now, the second part of the experiment, that is standardization of sodium thiosulfate solution. Here, conventional titration procedure is adopted. 20 ml of the made up K2Cr2O7 solution is pipetted out into a conical flask and add 3 ml of pure concentrated hydrochloric acid. About 10 ml of 5% potassium cyanide is added. The solution is diluted to 100 ml and titrated against sodium thiosulfate solution taken in the burette. The addition of sodium thiosulfate is continued until the solution is pale yellow in color. About 2 ml of starch solution is now added and titration is continued until the blue color changes to green. That is the end point. Now you have to repeat the entire titration to get the concordant values. Concordant values means 2 values in 2 adjacent titrations must be the same. Now, standardization of sodium thiosulfate. Now we are demonstrating the experiment, the titration for the standardization of sodium thiosulfate. Over to the calculation part of standardization of sodium thiosulfate. We have performed a titration and we have taken some weights and all these values are tabulated and we have to perform the calculation. For this, the weight of K2Cr2O7 taken equal to W1 minus W2, that is equal to 1.262 gram. Weight of K2Cr2O7 per liter will be equal to 1.262 multiplied with 4, that is equal to 5.048 gram. Here you are multiplying with 4 because you are transforming 1.262 gram of potassium dichromate into 250 ml standard flask. So, the volume per liter, the mass per liter is equal to 1.262 multiplied with 4, that is equal to 5.048 gram. Now, normality of K2Cr2O7 can be calculated by using the expression normality is equal to weight per liter divided by equivalent weight. That is equal to 5.048 divided by equivalent weight of potassium dichromate, that is equal to 49. So, the result will be, the normality of the K2Cr2O7 solution will be 0.1030 normal. Now, the titer value during the standardization can be calculated like this or tabulated like this. K2Cr2O7 into sodium thiosulfate will be the titration and volume of K2Cr2O7 pipetted out in 3 cases will be equal to 20 and burette reading are shown here, initial burette reading and final burette reading. The volume or the titer values are shown in the last column. Here you can see two values, the last two values are the same. So, the concordant value will be equal to 20.5, that you can take as the volume of sodium thiosulfate. And by using this concordant value of 20.5, you can calculate the normality of sodium thiosulfate solution using the relation N sodium thiosulfate into V sodium thiosulfate equal to N potassium dichromate into V potassium dichromate, and in the present experiment, N potassium dichromate is already calculated, which is equal to 0.1030 normal, and volume of potassium dichromate pipetted will be equal to 20 ml, and the titer value, that is the volume of sodium thiosulfate solution used, is equal to 20.5 ml, and you can calculate the normality of sodium thiosulfate by using the present equation, and you got the value as normality of sodium thiosulfate will be equal to 0.1005 normal. Now, the last part of the experiment, that is nothing but estimation of copper. The given copper salt solution, preferably the copper sulfate solution, is made up to 100 ml in a standard flask and pipette out to 20 ml into a conical flask. Ammonium hydroxide is added drop by drop till a permanent precipitate is obtained. The precipitate is redissolved by adding required quantity of 1:1 acetic acid solution. About 15 ml of 5% potassium iodide is now added and liberated iodine is titrated against sodium thiosulfate solution taken in the burette. Starch is used as the indicator towards the end point. The titration is continued until blue color commences to fade. About 10 ml of 10% ammonium thiocyanate solution is now added, and then the titration is continued until the blue color is just discharged. Repeat the entire titration to get concordant values. From the titer value, copper can be estimated, or the amount of copper in the given solution can be estimated. Now we are demonstrating the experimental part of estimation of copper. Over to experiment. Now we are entering into the calculation part of the estimation of copper. The titer value can be first tabulated like this. Here we are performing the titration of copper salt solution against sodium thiosulfate solution. Volume of copper salt pipetted in 3 cases will be equal to 20. Corresponding titer values are obtained from the burette reading, and the corresponding titer values are also shown here. It is possible to calculate the normality of the copper salt solution by using the relation N1V1 equal to N2V2. N1 represents normality of copper salt solution, V1 represents volume of the copper salt solution. N2 we already calculated, that is normality of the sodium thiosulfate that we obtained during standardization of sodium thiosulfate. V2, that is the titer value, that is equal to 19.8, which is the volume of the sodium thiosulfate used, and N1 equal to N2V2 divided by V1, that is equal to 0.1005 multiplied with 19.8 and divided by 20. You are getting the normality of the copper salt solution as 0.0995 normal. Now, weight per liter of the copper in the given solution is calculated by using the expression normality into equivalent weight, that is equal to 0.0995 normal multiplied with the 63.54, that is the equivalent weight of copper. You got the value as 6.322 gram per liter. Now, mass of copper in the whole of the given solution is calculated by using the equation weight per liter divided by 10. Divided by 10 is because you are made up the solution to 100 ml. That's why we are dividing it with the 10. So, you got the mass of copper in the whole of the given solution as 0.6322 gram. Now, the final results of the entire experiment is shown here. The normality of the given copper salt solution is 0.0995 normal. The weight per liter of copper in the given solution is equal to 6.322 gram per liter. Mass of copper in the whole of the given solution will be equal to 0.6322 gram. That all about the present experiment of estimation of copper. Have a nice learning experience. Thank you.